Imagine standing at the edge of a massive concrete cylinder. Beneath you lies the glowing blue water of a nuclear reactor pool, calm and still, but humming with invisible, unimaginable energy. Now imagine falling in. At first, it seems almost peaceful. The water isn't boiling, there's no explosion. It looks like any other pool, just bluer. But what's causing that eerie glow isn't ordinary light. It's called Cherenkov radiation, a kind of electromagnetic scream from particles moving faster than light can travel through water. That glow means you're not just in danger, you're in one of the most hostile environments on Earth. Within the first second, your body is bombarded with a cascade of high-energy neutrons and gamma rays. Your cells don't just die, they shatter. DNA begins to break apart faster than it can replicate. Your bone marrow, the factory of your immune system, begins to collapse. You don't feel pain at first, just warmth, confusion, a strange metallic taste. That's the beginning of acute radiation syndrome. If you're lucky, and by lucky we mean very unlucky, you might be pulled out within a second or two, but the damage is done. A dose of just 4 or 5 sieverts is enough to kill most people within weeks. In that reactor core, you just absorb 10 times that, in under 3 seconds. Your skin may look normal for now, but beneath it, your organs are shutting down like dominoes. Within hours, you'll start vomiting, your hair will fall out, your blood vessels will begin to leak. Within days, your body will become a battlefield of internal hemorrhaging and necrosis. Medical treatment might buy you a little time, but there's no real cure. At this point, even your cells are losing the ability to divide. The machinery of life has been torn apart. But what if you didn't get pulled out? If you fall directly into the core, especially in older models, where fuel rods are exposed in the pool, death isn't a slow burn. It's instant vaporization. The water around the rods is intensely radioactive, and at the source, the radiation is so powerful that it causes molecules of water to disintegrate. You'd be flash-cooked from the inside out. Your proteins denature, your cells rupture, and your body essentially disassembles itself before it can even sink. Within seconds, you are no longer a person, just a high-energy chemistry experiment. There's a haunting real-world case from 1945. Louis Slotin, a physicist working on the Manhattan Project, accidentally initiated a critical reaction during a lab test. He received a fatal dose of radiation and died in agony 9 days later. And that was from brief exposure. Falling into a modern reactor core would be orders of magnitude worse. And no, the water doesn't protect you. The pool in a reactor is there to shield others from the radiation. It slows down neutrons and absorbs stray particles, but only if you stay on the right side of the surface. Underwater, the radiation is concentrated and continuous. It's not just that it's deadly. It's that it keeps getting deadlier the closer you are. Ironically, reactor cores are not built to explode like in movies. They're designed to be stable, but they are also designed never to be touched. A human body doesn't trigger a nuclear reaction, but it doesn't need to. Just being there is enough to ensure your destruction, quietly, efficiently, completely. So, if you ever find yourself wondering what it would be like to fall into a nuclear reactor core, the answer is simple. It would be the most horrifying, efficient form of self-destruction ever devised by physics. And the worst part, you'd never even get the chance to scream.